Hey, um, we're using Climate Studio more starting this week with a focus on radiation map simulations. And I just thought I would make a video. I don't know if you guys need it. I definitely need it. I needed to go back over this because like I said at the beginning of the semester, I really haven't used Climate Studio very much. And I am always, I approach this from wanting quantities to come out of it, so that may not be something that you guys are going to want to focus on. The first point I just wanted to make was that Andrew asked me to write the assignment for this week, and I'll share it with you, you guys, or with, and Andrew may want to change it. Uh, it may be it may be different than what you guys think is important, or it may be too detailed, too complex. I don't know. So anyway, do whatever if you want to with it, obviously. I want to remind you that it's always a good idea, I think, to look at this Climate Studio documentation. There's a lot to this radiation map simulation, um, and they do a pretty good job of describing here. Well, definitely a better job than I would. Um, One thing to point out is that you really should define materials for your surfaces, in addition to telling the program which surfaces you want to run in the simulation. I've done some experimentation with that, and it really does change the outputs, which makes sense because the sun's reflecting off of those surfaces, and so that's affecting how much, how the whole area around it. The basic idea I had for this first foray into um, radio or Climate Studio really is to create very simple context models. And I think that, or at least what makes sense to me, is to start with not with their massing models, but with a box that has that's consistent on all the facings in terms of its surface area. That way, it's easier to compare the amount of sun that's hitting, or the amount of solar insolation that's contacting that surface. So to show how that's done, if you go to the CS workflows, and select radiation map under materials, then whatever and I'll share this file with you. Whatever you've defined as layers shows up in this materials section, and you can apply materials just by clicking on it. And I don't think it matters that much right now. I made sure that they were somewhat reflective. Um, and then for each run, you need to decide what you want to be in the model. So I defined, and again, this may not be what you want to do, but I think it's, for me, important to understand what's the differences between each facing. That's kind of the point of this initial exercise. So I named each face of this box, north, south, east, and west. And, you can, by the way, in case you um, don't remember this, if we come back to slide analysis, I think it's where it is. Oh, actually, it's here. You can turn on the compass, show compass. Um, so I'm making sure that students have the compass on at all times for these things, for these exercises. Um, so here we are in our radiation map. We have set our materials and defined surfaces for all of these. I have a mass, which is the object in the middle. I have ground, this is the ground, obviously, I guess, and then 3 different contexts that I've created. Another thing to realize is that you can turn on and off the simulation. So if I turn it off here, I'm back to just whatever is showing in my layers. It can get, if you don't know that, it can be frustrating because whatever simulation you ran last is what you're seeing. And we can always either turn the sun on or off back in. If we go back to our slide analysis simulations, we can turn the sun on or off. So then I've just run a series of simulations here, and I'm not going to run any right now. I guess maybe I'll run one at the end. So they go very quickly. Actually, let me go back to this. If I'm switching to my radiation map. Obviously, I'm going very quickly. If this is helping you, you can pause and see what I'm clicking on. I think I'll try to be clear with showing my mouse. If So one thing to realize is that each of these surfaces has some sensors on it. I set these, I think that's the default, and you may want to change it. But if I edit these, we're at the sensor spacing is 16. I think that's every 16 feet um, in an array. So that means, and I went ahead and made these, my massing model in the context of our assignment or our project. So it's basically 30 feet, 30 foot square is the footprint. So that's only two of these sensors per, well, two per face, I think. So that's not very many, but it makes the model run very quickly. And so I set a ground and a context. So this is my ground, made it whatever size. And then I have different contexts that I set that for specific reasons that I was trying to test things. Then if I will go ahead and run. So right now I have chosen all of these, uh, just my building and the ground. I have my location now. Right now is at LaGuardia in New York City. If I run this and go to my results, I very quickly start getting results. It's not over yet, but it'll be over in like maybe 10 seconds. Um, and there's a lot of information here and a lot of things you can do. That's where it would be good to remind yourself of just look through this radiation map uh, documentation to see what all the different options are. I'll go through a few of them, but I may forget some. First off, you can define whether or not what insulation we're looking at. So, for example, I could just limit it to direct solar exposure as opposed to any that's indirect or reflected, or do total. I can change the hours that I want in terms whether or not it's hours where we need heating or cooling, or all hours. To me, that one of the really great things about this model is that we're getting now specific kBTUs um, per day or per square foot per year for our different facings. So I think that that's really useful. And so anyway, the other thing that I think is important to tell students is that they should name these runs. So I'm just going to name this test. If as you name them and you move back and forth between the things you're doing, it will reorient them in alphabetical order. So it's and the only way to for this to be useful is if you name these in a way that you understand what you're changing with each run. So let me just run through some of these to show you what I did and what I think is a decent model for doing this. So first I ran in New York City. I ran just a straight up clean site with my massing model in my ground. Then I added context and compared it, and you'll see that I'm changing the amount of insulation that's hitting the site, even with this and this is sort of interesting too. I think this is why this is a good thing to always be going back to our site analysis tools. If we look at this, let me go turn off my simulation. Let's just say we're looking at the sun path, and with that first context in place, it never really interfaces with the building. So if I go to like to noon and run through the year, actually let me get back to noon. Sorry, I wasn't really being clear there. I'm at noon. We're never really accessing a shadow. A shadow is not hitting our face. But if we go and look at our studies, so for example, on the south face here, just the radiation without, so let me get rid of it. Let me go back and turn on the actual simulation and turn off these here. So, and I guess I'll go turn the sun off too. So we're looking at New York City, just a radiation map without any context. Just looking at the south, we have 684 kilobtus per day, or let's just say 416 kilobtus per square foot per year. If we then add the context site that we just saw does not actually put a shadow on the building, we do have a fair amount less insolation hitting the building, 416 here, and 388 here on the south side. So the point is, if we're quantifying and we're using a more detailed model, we get more information than we do with just the visuals. And it's different information, obviously. Then I just chose different context sites to add and saw how they affected my solar insolation on different facades, totally as an experiment to try to understand how this is working for my, and then I did this for both sites. So Phoenix, same thing, comparing them, looking at, you can do them very quickly. And if I'm organized, then I can go back and look at these results very quickly and compare the quantities. We have the same range of, the 0 to 650 kilobtus per square foot is the range for all of these, so that the visuals are consistent. Anyway, so that's the first exercise that I put in this assignment. And the idea is that I am working with is that then, so they start off with that. I also threw one in, Andrew and I talked about this. I think it's a good idea. First of all, we're going from climate consultant and climate studio back and forth. And so we've really been focusing more on climate consultant. So now as a way of sort of making this transition, I think it's good to compare the charts in both, right? Because if we, I don't have climate consultant open right now, but if we're going back to our site analysis stuff, we have the same charts here, or some of the same charts here that we have in climate consultant. And, Andrew and I quickly looked at a couple of them, and as would make sense, at least for this one that's plotting the temperature, the wet and dry bulb temperature, and the different irradiation types, they're exactly the same, it seems, because it's just data from the same EPW file, so it should be the same. Though there could be rounding, I don't know, and I would spend more time myself just trying to see if they're always that way. But they are, the units are different and they're laid out differently, so it's not immediately clear to see the differences. And then if we go to the windrows, it's not immediately clear if they're exactly the same. And I think that's a good point to make to students is that, these are models and there's a lot of math going on in the background, or there's data coming in from a source. We don't want to trust these just, without using our critical thinking skills to make sure that we're confident that we're comparing apples to apples. And a really good one to think about is the windrows, which is very different how they're displayed and the information that's in the windrows in Climate Consultant and Climate Studio. They're both great, but they're just different. Okay, so that was the first in the assignment. That is, I realize I'm going on. Of course, you can just turn this off whenever you want, but this just makes sense to me. That's this first little exercise really quick, just getting them to check that. Then the one that I just was talking about is this second one, the solar-driven siting. And then third, I'm saying they should go ahead and choose a site. Oops. I'm telling my students that they can either take the site that I built, which to me is, not that great. Obviously, I just kind of quickly put it together. I would have made it larger, I think. if I were doing it again, just because the solar studies I think are confusing if the sun goes outside of the context of the little box that I made, or the topography I made. I can make a in SketchUp. I can very quickly create geolocated topography because it comes in automatically. And I am offering to show my students that I know it costs $55 per year to get a SketchUp license, and I know there's some kind of resistance in NYIT, in our department for using SketchUp for some reason that I don't quite get. But this is not, sort of breaking that rule because we're talking about just bringing in not that it's a rule, but just bringing in um, a topography from a different program and then using it in Rhino. It's much easier to do. And so if anybody has interest in that and doesn't know how to do it, I can show you guys how to do it very quickly. Um, anyway, so then the final thing that they would do would be to choose their site, either create it or open the one that we gave them, then bring in their massing models to that site and start iterating the form of their proto design to maximize the desired effect that they're trying to have utilizing the solar resource on that site. And to me, that means that if they're making their own site, they may want to sort of game it to where it has certain features that will be an advantage to the specific climate that they're designing for. And then they're using that same site in two climates, but they're able to move their building to different siting locations on the larger context site, which I think could be really interesting. And if they're careful, if they're doing what I'm asking them to do, which I don't know if they are yet, is to generate consistent graphics that are comparative. I think we could end up with some pretty cool stuff in the end if we use the same topography, but let them cite their designs in the two different climates on different places in that topography. So that is this part of the assignment, and then there's a very simple description of deliverables, which maybe should be clearer. I don't know. I mean, I never know how much to say on this. I mean, not clearer, but maybe more detailed because I'm not saying exactly what they should turn in. So you could adjust that if you wanted to. Anyway, sort of long-winded, but maybe that's helpful. It was helpful for me to do it. So at least I've accomplished that. All right. I will talk to you guys when I talk to you.